Okay, so let's start taking all of the various identities we've learned. Admittedly, the first two videos are just like, here's a formula, here's a new formula, here's another formula. Now let's start using them, and we're going to work through several problems. So the sine of theta is a third, and cosine is negative. Find the exact value of each of the remaining 5 trigonometric functions. This type of problem is always given on the midterm. Okay, I used to write the midterms for all the sections. I've handed off that responsibility to someone else, but they're still pretty similar. This sort of thing always shows up. Given the value of one trigonometric function and some other bit of supplemental information, like the cosine is negative, find the exact value of all of them. You always want to start this problem in the same place. Okay, use one of the Pythagorean identities. The Pythagorean identities were sine squared theta plus cos squared theta equals 1, or tan squared theta plus 1 equals secant squared theta, or cotangent squared theta plus 1 equals cosecant squared theta. So what you want to do is see which one of these is most relevant. Well, since we have a sine and a cosine given, most specifically, since we have a value for sine theta, we're going to use this one because it has a sine in it. So since sine of theta squared plus cos of theta squared is equal to 1, I know sine of theta is a third. What's 1/3 squared? It's 1/9. Subtract the 1/9, we get cosine of theta squared is 8/9. Take a square root. So cosine of theta is plus or minus the square root of 8/9. Now we need that extra bit of information. Cosine was told to be negative, so I'm going to take negative 2√2/3. Okay, I want the negative one. Now that I have the sine and the cosine, all the rest fall into place quite quickly. Okay. So this is exactly how they're going to start. Sorry, let's skip that writing. Let me just finish it with what we had done. So we've determined that the cosine of theta is negative 2√2/3. We also said the sine of theta is a third. Okay. By the way, this is always a 10-point problem on the midterm. You're given one trig function. Each of the remaining ones are 2 points. It's pretty quick to grade. So cosine of theta is given. That's only 2 points, but it was the hardest one to get because now I can get, for example, tangent of theta is just sine of theta over cosine of theta. Sine of theta is a third. Cosine of theta is negative 2√2/3. As far as I'm concerned, you can actually leave it like that. But if we cancel out the 3's, we get negative 1/2√2. You can definitely leave it like that. But if you really hate radicals in the denominator, this is negative √2/4. So we've done cosine, we've done tangent. What else can we do? Secant theta is just 1 over the cosine of theta. So that's just negative 3/2√2. I just flipped cosine. If you really hate radicals in the denominator, negative 3√2/4. Sine of theta was a third, so therefore cosecant of theta is just 1 over that. 1 over a third is just 3. And finally, cotangent of theta is cosine of theta over sine of theta. Alternately, it's just 1 over tangent of theta. Since we already determined tangent of theta up here, I just reciprocate that and I get negative 2√2/1. Okay, so that's generally how I would do this. So write down what you would like. The most fundamental part was starting with a Pythagorean identity to get one more trig function. And as soon as you have 2 of them that are not just reciprocals of one another, so if you have sine and cosine, you're done. If you have tangent and cosine, you're also done. Because from tangent, you have sine over cosine. If you already know the cosine, you can find the sine, and then you can fill everything in, etc. So you're really using your starting information plus a Pythagorean identity to get 2 possible versions for another one, but there's going to be a plus or a minus. And then you're going to either be given something about what's positive versus negative, or you're going to be given some quadrant information from which you determine what's positive and negative. Okay, so copy down what you like. Pause for a moment. I'm just going to get this out, and then we'll do it the way the book does it. Okay. So the first way the book does it is using a circle. So since sine is positive and cosine is negative, so that we were given sine was positive and cosine is negative, we must be in quadrant 2. Okay. The way they're going to do this is using a circle that isn't the unit circle. Remember, in a circle of a different radius, the sine of the angle is y over r. So I want y over r to be a third. We can do this by letting y be 1 and r be 3. So now we're not in a unit circle, but as long as we remember to account for this radius of 3, it's okay. Now that we're on a unit circle, x squared, sorry, not on a unit circle, x squared plus y squared isn't 1, it's r squared. And if r was chosen to be 3, our fundamental equation is x squared plus y squared equals 9, r squared. So now I use that fact to get y. So y was 1, sorry, so we use that fact to get x. X is the square root of 8. How do I know it's negative? Because I'm in quadrant 2. So x had to be the negative square root of 8. Since x is given, y is given, and we specifically picked r equals 3, then you can just fill in the rest. This is fundamentally similar to how I did the problem, except I did it where r was 1. Therefore, y was 1/3, and x was negative 2 root 2 over 3. After that, it's all the same. Okay? If you are comfortable working with circles of different radius, that's okay. If you'd rather always work with the unit circle, that's also okay. And I tend just mentally to be like, if I already know one way to do it, I'm just going to do it that way. So since everything is based in the unit circle, I always tend to do it the unit circle way. But this is how you can do it with other circles, that's fine. There's another way you can do it, and this is how we did it. Okay? Using the trigonometric identity, this is based on the unit circle. That's sine squared plus cos squared equals 1. In other words, y squared plus x squared equals 1. So this is how we did it. This gives us, sorry, if you just solve for cosine, it's plus or minus the square root of 1 minus sine squared. We were given cosine is negative, and that sine of theta is 1/3. So we plug that in, and we get out exactly what we had for our cosine. Now that you have sine and cosine, you just charge through and you compute everything else. And this is all stuff that we had done on the previous slide. Okay, as I've said, this is a very typical type of midterm problem. Given that tangent of theta is this, and you're in quadrant whatever, solve this. Okay. So here's another example. Okay, we want to be given the value of one trig function and what quadrant we're in. Then you can find all 5 other trig functions. You can do it this way using a circle of a different radius, okay? And you just have to remember to account for that radius in all of your definitions, sine, cosine, etc. The other way I would do it is assign values to x, y. Oh, sorry, this is the same technique, sorry. So you have variables x, y, and r, and then you're going to use the circle of radius r, x squared plus y squared equals r squared, to find missing things and then fill it in. The other way, which is the way I tend to do it, is to use a Pythagorean identity and go from there. So for example, given that the tangent of theta is root 3 over 3 and the sine of theta is negative, find the exact value of everything else. So let's do it first the book's way, where we can make a circle of whatever radius we want. Well, the first observation is that tangent is positive, but sine is negative. Therefore, cosine must also be negative. Okay, in order for this ratio to have been positive, since sine was negative, cosine must have been negative as well. Since both sine and cosine are negative, I must be in quadrant 3. Okay, so now I say I have an x and a y, and I have an unknown radius r. But I know I want the tangent of theta to be y over x. But I know the tangent of theta is root 3 over 3. So the easiest thing I can do is make my y-coordinate negative root 3 and my x-coordinate negative 3. I don't want to use positives because I know I'm in quadrant 3, so I know both of them are supposed to be negative. But we're just taking numerator, numerator, denominator, denominator, and making sure I put the correct sign on it. But notice we are not in the unit circle in this approach. So what we do, now that we have a given value of x and y, we compute r, using the fact that x squared plus y squared equals r squared. So x squared is 9, y squared is 3, so r squared is 12. So r is the square root of 12, which does simplify, let me get my marks out of the way, to 2 root 3 if you prefer. So our circle is x squared plus y squared equals r squared is 12. Okay, we're not doing the unit circle approach here. So now I have a value of x, a value of y, and a nice specific value of r, and now I can start filling everything else in, accounting for that radius r. Sine is y over r, which simplifies to negative 1/2. Cosine is x over r, which you can reduce down to negative root 3 over 2. Cosecant is r over y, which just becomes negative 2. Alternately, it's just the reciprocal of sine. Secant is negative 2 root 3 over 3, which is just the reciprocal of cosine. And fill in your cotangent just by reciprocating your tangent and just getting root 3. So that's one way you could do it. The other way, which is how I would do it, so we were given the value of tangent, which means the trigonometric identity that helps me is the one that has a tangent in it. Tan squared theta plus 1 equals secant squared theta. We need the same bit of reasoning that since tan is positive and sine is negative, we must have cosine be negative and we must therefore be in quadrant 3. Since we're in quadrant 3, secant is also negative. So the Pythagorean identity was tan squared theta plus 1 is secant squared theta. Tangent was given to be root 3 over 3. So I square that, and it becomes a third. So the secant squared of theta is 1/3 plus 1, which is 4/3. So secant theta is plus or minus the square root of this. But since we're in quadrant 3, we already knew that secant was negative. So I'm going to take the negative square root of 4/3, negative 2 over root 3, aka negative 2 root 3 over 3. Now we've solved for secant. So now I know tangent is this and secant is this. Therefore, cosine is 1 over secant, which simplifies down to negative root 3 over 2. Cotangent is 1 over tangent, which simplifies down to root 3. The only one that's missing now is what's the sine? Well, there are two ways to go about it. Let's just follow this one. We know the tangent and the secant. So tangent is sine over cosine. If I multiply both sides by cosine, sine theta is tangent times cosine. And we already found the tangent and we found the cosine. So just multiply them together for negative 1/2. The other way you can do it, by the way, well, actually the way I was about to present is fundamentally the same thing. So once you have either sine or cosine, if you have tangent, you can find the other one. Cosecant, now that I have sine, is not an issue. Okay, now that we know the sine of theta is negative 1/2, the cosecant is just negative 2. So again, totally typical exam problem. Given one trig function value and some bit of information, something is positive, you're in a certain quadrant, find all the rest. So practice that a bunch. It will help you get 10% of the midterm done quickly, and 10% is a full letter grade. So good. All right, so we're going to wrap up with a little bit about even-odd problems. So the sine function is odd, but, oh, come on, pen. Sorry. There's a particular button that's very easy to accidentally push on my tablet pen, which turns it into that weird drawing mode. So sine is odd. In other words, the sine of negative theta, the negative sign can be factored out. Cosine is even. You get to ignore a minus sign on your input. From those, you can determine the rest. So let's understand why these are true. So we start from here and I rotate in this direction, and my y-coordinate is the sine of the angle. But what if I did negative angles instead? Instead of going up, I'd go down. I would do exactly the opposite. However, if I rotate this way and I look at my x-coordinate, if I rotate this way instead, my x-coordinates haven't changed. Okay, rotating here versus rotating here, while it switches the y-coordinate, the x-coordinate is the same. So the sine function is odd. It switches positive and negative, but sine is even. It doesn't care whether you're doing positive or negative angles. Now let's see why, with those two things under our belt, all of the rest follow. Well, let's take a look at the tangent of negative theta. This is going to be sine of negative theta over cosine of negative theta. In the numerator, sine, I factor that minus sign out. But in the denominator, cosine is an even function, I ignore it, and now sine over cosine is just tangent. So tangent is also an odd function. Okay, since sine is odd and cosecant is just 1 over it, cosecant is also odd. Since cosine was even and secant is just 1 over it, secant is also even. And since tan is odd and cotangent is just 1 over it, cotangent is also an odd function. So let's just do a sample problem using this sort of stuff. So find the exact values for each of the following. So sine of negative 30 degrees is going to be negative sine of 30 degrees. I really prefer to work in radians. 30 is pi over 6. And the sine of pi over 6 is a half, so it's negative 1/2. Okay, so use similar tricks to try to do the rest. Okay, hopefully you paused and worked through them. Let's present the solutions. So let me clear my marks out, because they're going to do the first one, of course. Okay, cosine is even, so ignore that minus sign. What's the cosine of pi over 3? You just look at a reference circle and you get out a half. Okay, cotangent, tangent and cotangent are both odd, so factor that minus sign out. You can either look at a reference circle, you can also use periodicity, but the cotangent of 5 pi over 4 is -1. It's 1, sorry, so negative that is -1. And lastly, tangent is also odd, so factor it out. Now 29 pi over 4, use periodicity. It's pi over 4 plus 7 whole copies of pi. That would be 28 pi over 4. Since tangent period of pi, I can ignore that 7 pi, so I just have negative tangent of pi over 4, and tangent of pi over 4 is 1, so the end result is -1. So that concludes, sorry, I'll bring that back up in case we're still writing. But that concludes section 6.3. We learned a whole bunch of properties of our trig functions, Pythagorean identities, even odd properties, periodicity, and we learned a really fundamental type of problem that, again, I am guaranteeing you will be important for the exam. Given one trig value, cotangent of theta is 8, and you're in quadrant 1. Can you fill in all of the rest? So you can do it with circles of arbitrary radius. If you're comfortable doing that, that's totally fine. I really prefer to work through the trigonometric identities. So in that one, tangent of theta is 8, so I immediately say use the identity tan squared theta plus 1 equals secant squared theta. And then from there, I can find secant theta. From secant theta, I can find cosine. If I know the tangent and I know the cosine, I can find the sine, and now you just fill everything in and you're done. That's how I recommend to do it. If you like the other way the book presented, of course, you can do it that way as well. All right, so that'll be it for this. Come back later for section 6.4.